Hello, Saxo fans. Episode 30 something, not entirely sure. Right, on the bench in front of you and on your screens is a collection of carefully selected components. Now, the reason why these are here is because I need to get them balanced, and that's the reason why I haven't progressed the engine build anymore, and maybe why you're all sitting there going, come on, just build the thing. Obviously I want to do it properly, and the next step for me is to get all of the rotating assembly stuff balanced properly. So that entails two things really. Dynamically I want to get all of the rotating assembly done, so I needed to get the flywheel, so I've gone for a TTV billet flywheel that takes 184mm clutch. So this is a racing flywheel, much lighter than the original one. I'll weigh that. I think my scales only gets up to 5 kilos, so I think this is a 3 kilo or so flywheel, and the original was probably about half a ton. And obviously the clutch is way beefier than an original clutch. It's a twin plate racing clutch, 184mm. Should hopefully be more than up to the power that I'm looking to run. So it might give me quite a heavy pedal, but that's a sacrifice I think we're gonna have to make. I'm gonna have to do that with any clutch that I go for. The compromise I can go to then is I might have to move to a hydraulic actuation, but we'll cross that bridge I think later on. Now the reason why all these are here, because I want to get them all done together, because obviously they all rotate together. So essentially obviously clutch bolts to the flywheel, flywheel bolts to the crank bolts to the timing pulley, front pulley bolts to that, and obviously all the bolts associated with it. Obviously that'll all get balanced dynamically, so it's perfect. We're going to go for a knife edge crank as well, just because we can. So I think all of that together will be brilliant. And then static balanced, we're going to have the pistons and the rods balanced as well. I think they'll be pretty close, to be honest. I can't imagine they'll be too far out, but essentially they'll take the lightest one and machine down the other ones so they're all the same as the lightest one on both the rods and the pistons. And that should mean then we are fully balanced. And then hopefully I can bring it all back, and by that point I'll have all the bearings and stuff, and the block will be painted, and we can rebuild the engine. That's certainly the intention. So I'm hoping that the company that I give this to will do some footage for me of them balancing, but if not, then we'll just go straight to painting the block, I think, because that's probably the next logical step. And then once all these come back, I'll show you what they've done. If you can actually see that, probably not. You might be able to see the knife edge crank maybe, but other than that, it's just going to be little shavings of material that will come off them. So anyway, I'll leave that where it is for now, and for now what we're going to do is go straight to painting the block. Right, and Saxo fans, the block. So it has been sat on the shelf, covered in WD and wrapped in some plastic sheet for a couple of weeks, or however long it's been since I got it back. I am now ready to paint it. I don't want to de-oil all of the inside because obviously that's protected. I only obviously really need to paint the front face here and the opposite side. I don't need to paint the front here. I don't think I need to paint much here. There's a little bit maybe that can get painted on this end here. So what I'm going to do, rather than stick this whole thing in my parts cleaner, which probably I could fit it in, but it's quite heavy and I might bend it. So what I've got is just a load of degreaser in my bottle here. Just going to give it the beans on this, and then we'll go to town with some rags and get it de-oiled, ready for paint. That's the plan. So cue the time lapse. Right, Saxo fans, engine block has been painted. dried overnight, all looks good. A couple of little patches where I've missed, so I'm just going to go back over it a little bit and get those covered. And then we can stick the block onto the engine stand and get ready for the build. So I'm really happy with that. Now, the next thing I want to talk about is garage and murder tent. So let's just touch on that quickly. Right, and Saxo fans, it is Christmas. A couple of days before, the Saxo is in the garage. She's finally in. It's been about 6 months outside, under a cover. But obviously, as you know, 2 years essentially working outside, and the garage is done. So there's a couple of little bits to tidy up. So I'll just give you a quick garage tour, and you can see where we're going to be working over the next few months. Let me just swing you around. So car fits reasonably well, got slightly more room down either side than I did in the murder tent. The murder tent used to come up at an angle, which really limited your space. You had sort of same floor space, but it was tighter on the side. So I've ended up essentially with a little bit more than what I would have had in the murder tent. And then I'll go tell you how the car's survived. Bought myself a bit of racking, obviously standard garage fare. So I bought all the refurb bits back into here now, so that's all waiting. Got myself a blingy new toolbox. This is from SGS. That's where all my sandblaster and compressor and everything's from. So essentially I'm going to be building the engine here. Yeah, and a bit of racking, plenty of light, nice big skylight, and obviously the Saxo's inside. Job's a good one. Happy with that. So really good space, nice and bright, nice and airy, and of course most importantly dry. So how did the car survive? Let's touch on that briefly. So as you know, the car's been under a cover for the best part of 6 months, and my builder, thoroughly nice guy, wasn't super sympathetic to our possessions, if you can read between the lines. So as a result, the Saxo has suffered a bit, essentially just dust and dirt. So you can see sort of the build-up of crap in there. So essentially it'll just need a good hoover and a good rinse off. Really dusty, everything. And I will confess, so when I did the engine bay and wrapped it, there's no rust at all in the engine bay. All my plating's hung up. It's done really well. So this has done great, because when I did all this, obviously I stripped it back, deoxied it, hydrate 80, primered and painted. When I did underneath, I didn't use any hydrate 80. So at the back, at the underneath, there's a few spots that have started to go rusty again. So I'm going to spend probably a couple of weeks just getting under there and sorting those out. Obviously I've spent a lot of time getting it right, so I'll just get those rectified, and then obviously get all this up in the air and wheels off and all that kind of stuff, and de-dust everything. You can sort of see the suspension down here, how dusty it all is. So all that just essentially needs to come off and be cleaned, and nothing's tight at the moment, so it's nice and easy. You know, there's no torque applied to any of this, so it should be quite easy just to strip it apart, clean it all off, put it all back on, ready to go. So yeah, a few steps backwards, but I think ultimately worth it. And of course now I have this area over here where I can build my engine, as I said earlier. So the next thing I'm going to do is bring the block in, which you just saw me paint, and that's all been dried and has dried overnight. So I'm going to bring that in here. Let's get on with that. Well then guys, so everything's now back from the balancers and we can crack on with building the engine. Very quickly then, the flywheels had some material taken out of the back or the inside. We've got a few drillings here to dynamically balance that. The clutch is now in a fixed position, so I will have to reassemble it in that particular way. The pistons are now all weigh exactly the same. There's two of them have been machined on the back to weigh the same as obviously two of the others. So pretty good from Wiesner that had two that are identical. So that's sorted. The crank, I was going to go knife edged, but decided not to. I didn't want to take any of the strength away from it, and it's not really required for a turbo build, I don't think. So essentially all that's happened here is that's been balanced with some material that's come off a couple of the counterweights. You can just see that one there. And then the same deal with the cover rods. These have had a bit of material taken off them in key places to make them all the same. So essentially that's all done, and the same with the front pulley as well. So everything is balanced. We are ready to go. A couple of things that need to happen. Obviously, I need to measure my clearances. I've bought my bearings, ACL race bearings, mains and big ends, brand new thrust washers. So we'll get all of that stuff done. I don't have mega expensive kit to measure clearances, so we're going to have to go with the old trusty plastic gauge. So I'll run through that process. We'll measure end float. We'll do our piston ring gaps as well before assembling all of the pistons onto the rods and all that kind of stuff. But the aim really now is basically to get the bottom end up to a point where it's done. The only thing I probably won't be able to do at the bottom end is put the sump on, because I need to get the boss welded on for return oil feed from the turbo. Anyway, so this is taken about 2 or 3 weeks since I dropped it off. There's been quite a big gap, and the reason why I haven't released a video for some time, obviously over the Christmas and New Year, and of course moving into the new garage. You know, the car's in here. Give the Percy pig bag. But yeah, obviously car's in here, and I've taken the fuel tank back out just because it was so dirty. I wasn't happy with leaving that in, and yeah, the rear beam has come back out again. So basically just sort of going back a bit just to get it back to where it was really. And of course I've been doing a few other bits and bobs. So if you follow my Instagram feed, you'll have seen that I've got a mild case of OCD. So using this shadow foam material, it's really good stuff, and obviously it satisfies the need to be neat and tidy. So yeah, it's really good stuff. Really love it. Great product. It's not super cheap, but it's not like mega expensive either. Basically, I think to do my whole toolbox, there's still a few drawers that I haven't even touched yet that have got shadow foam in there, but I haven't actually cut anything into them. To do the whole toolbox, which is we've got 15 drawers, 72 inches wide, it's about 160 quid of foam, and I've got loads of offcuts as well down there. So I made stuff like that little sign over there. Anyway, right, so first things first then, let's crack on with the build. Gonna get the crank in the wash, run the little brush through all the journals, make sure it's all like super clean. We want it a nice hygienic build, and then we're going to get the bearings in, fitted, drop the crank in, and we'll do some clearance measurements to make sure that we are all happy. Right, okay, so to the parts wash. Right, Saxo fans, time to measure clearance. So as you saw, pop the crank in, bearings are in, all that, thrust washers went in, oil control, or sorry, squirt jets went in. What I want to do with these, I'll put the new bearings in the caps. I'm going to put the tiniest waffer of oil on here just to lubricate, and I don't want to I don't want to be spinning the crank over, because obviously if I put loads of oil on, it adds to the clearance calculation. So I want essentially just enough to, not score the bearings or anything like that. And then we're going to put the plastic gauge in. So I bought a brand new kit because mine had been in my toolbox for probably the best part of 15 years and it had been squished, so it was no good anymore. I bought just one of each just because I couldn't quite remember which one I needed. Turns out we're going to be on the purple one. So this is in millimeters. They do give you inches as well. But the clearance for main running bearing clearance is 0.01 to 0.036. So on this particular gauge, 0.035 is this point here. So if we are squished this much, we're okay. Anywhere above that is also okay. This only goes to 0.018. So I could potentially be a little bit wider than what's on here. I could even go up and use the red if I wanted to, and potentially get into this region as well. So we'll see where we get to on this particular gauge. If we're off the top of it, then I'll go to a red and check we need to be here, because this one here is 0.038, obviously on a slightly thicker gauge. So I'm not going to use the green one at all. So that's what we're going to do. I'm also going to use the old main the main bearing cap bolts. I have got brand new ones for this, but I only want to use them once. So I'm going to torque all these down just using the old bolts, and then obviously when I take it all off and rebuild it for the final time, then obviously I'll use the new ones. Quite simple really. So let's cut a few little lengths of the plastic gauge. Don't know if you've seen this sort of stuff, but well, you probably have, but yes, tiny stuff really. You have to be really delicate with it because it's very small. And we'll measure the clearances. So first of all, we'll just pop this onto the journal on the engine. Right guys, got a little bit carried away and totally forgot to film any of the plastic gauge measurements. But in the openness of transparency, I will tell you what I got. So as you know, I used the purple plastic gauge. And on here, I needed to be, according to the Haynes manual, I needed to be from 0.38, so somewhere from in between those two, obviously up here, and then probably just potentially just sort of somewhere off the gauge here at 0.001. I actually ended up somewhere in between these two, so just fractionally off the top of the spec. And I did obviously put a bit of oil in onto the bearings as well, which essentially means my clearances are probably larger than what they should be, but only by the tiniest of margins. So unless I'm going to go and get my crank reground and obviously go for an oversized bearing, there's not a lot I can really do about it. So what I am going to do is leave it. Obviously that's a risk, and I think it's one I'm willing to take, given that it is only just off the top. If it was miles out, then obviously I'd probably feel a bit differently about it, but it is only just off the top. And as you can see, I can turn this over really easily. One finger job. Obviously it should be that way. So I feel like it's going to be okay. I'm sure there's plenty of you out there going, whoa, it's out of spec, don't do it. But yeah, I'm not going to go and get the crank reground and put an oversized bearing into it. I'm just going to leave it. Anyway, what I did do was put my new bolts in. So as you know, I said I used the old bolts to do the measurement, because obviously they've got to come in and out a few times, and I only wanted to put these in once. So that's what's happened. They've all been torqued. You'll notice that these four here are different, and that's because I have a Peugeot Sport sump baffle plate that goes on, that sits on there like that, and that's obviously supported by those 4 main cap bolts, hence why they're different. So that's all done. Next thing we're going to do is measure the end float, and hopefully that's in spec. Right, DTI is set up, it's just on the counterweight on the magnetic base there. We're all zeroed, so each one of these major marks is 0.1 of a mil, so 0.1, 0.2, 0.3. We need to be between 0.007 and 0.027. So somewhere around here would work. Let's have a look. So that's saying at the moment we are 0.015. We'll do a few measurements, we'll go back to back. Just sort the zero out. Okay, we're zeroed. Yeah, 0.15. Yeah, 0.17. This is the world's worst gauge. Yeah, 0.17 again. So, fairly happy with that. We're bang on in the middle of the tolerance. So, end float is all good. Right guys, time to measure the ring gaps. Now then, Woosner supply obviously a brand new ring set for the engine, obviously a complete piston set. Obviously you get top ring, second ring, oil control ring. They obviously have to go on in a particular order. We need to make sure the ring gaps are correct. Now, for those of you who don't know what a ring gap is, let me just explain it to you. So when these go on the piston and get compressed into the bore, this gap here will really close up, and that gap needs to be controlled. So that needs to be a certain measurement, and we do that by doing a quick bit of maths. So we'll take our bore size, which obviously I've got written down. So for example, let's just say one of these bores is 78.88 millimeters. We'll convert that to inches, which is 3.105. And then Woosner tell us what the gap should be for a boosted application. It's different whether you're NA or whatever, or nitrous and stuff like that. So for a boosted application, our top ring, we have to times the number by 0.0055. So 3.105 inches bore size times by 0.055, and that gives us a desired ring gap of 0.017. And what we do is we get our feeler gauges, go to the correct number, and that should be the size of our ring gap. Pretty straightforward. So what we'll do, the live exercise, I will pop in one of the rings and we'll check the gap on it. So I'll pop that in there. I'm going to use the actual piston itself to square it up. Like that. And we'll check the gap. It looks very small to me, but we'll see. Okay, so what I've just popped in there is 0.011 of an inch, and it's just starting to bind. So this ring gap obviously is too small. So what I'm going to do is go along, measure them all, mark them up, and then I've got a fancy little tool for just grinding away just a tiny part at a time, which I'll show you how to do that as well. So let's measure all of them, get them all laid out, and then we'll modify them and put them back in. Right, ring gaps have been measured. So we were aiming for top rings 0.017, and that was the same across the board. And the second rings we were aiming for 0.02. We actually ended up with about 0.01, 0.11 on the top, so a bit to come off all of those, and 0.017 for all of the second rings, apart from one of them, which was a little bit tighter. So yeah, a little bit to come off all of them actually. So I need to dig out the grinding tool, and yeah, we'll go through how to essentially take a small piece off each ring. I did just want to give a shout out to a chap called Simon. You know you are. Thanks for all your help. It's been about 15 years since I've built an engine. I've built these before, and I've built loads of stuff at work, but not for a while, so I'm a little bit rusty. But yeah, Simon's been a great help in reminding me how to do all this stuff. So thank you. Anyway, yeah, let's dig out the grinding tool. I'll do one, fit it, measure it, show you the difference, and then yeah, then I'll do the rest in fast forward. Let's get on with it. Right then, so ring gaps. My little tool is here. So got a little grinding wheel here on a handle and two posts. So what we do, obviously we know the gap of this particular ring. We'll pop this in, we'll push it up against the posts on one side of the grinding wheel. So this side of the ring here is just touching that wheel. I've already done this one, so I'm not going to do any more. But essentially I'll just put a light pressure onto that, and I'll spin the wheel over, and obviously take a bit off, stick it back in, measure it, keep going until essentially you've got what you need. That's nice and easy. So I've done this one. So if we pop this one in, so this one it started life out at 0.017. Pop this one in. And we want to be doing the ring gap sort of, an inch or so down, or centimetre or so down the bore. So we started out at 0.17, which is, on the gauges, so 0.17 is this one here. That now feels very nice and loose. And then if I skip a couple and go to a 0.19, just tight. 0.2, yeah, that's where we need to be, a 0.02. I can just get that in. Obviously it's got a nice little bind to it, nothing crazy. If I go for a slightly oversized at a 0.021, which is above, yeah, I mean, I can push that in really hard, but I'm having to be quite forceful with it. So I'm fairly happy that the ring gap is good. So that's one of them done. Job's a good one. So obviously I've got another bunch to do on all of them, so I'll go across and get all of those right. Okay, so I'm very aware now that this video is, over, probably coming up to half an hour long, so I do want to just stop it there. However, I promise you the next video is going to come out very quickly, because obviously I've got what I need and we're going to finish off this bottom end. So stay tuned, probably see you in about a week maybe, but yeah, see you soon and we'll finish the bottom end.